I'll text him right now.
Well, hey gang, if you're ready, we're ready to go. We're raring to go. It's a SBAU Astro Hour for Monday morning, May 11th through Sunday, May 17th, and all courtesy of SBAU, the Santa Barbara Astronomical Unit. It's our town's longtime telescope and astrophysics club. My name is Ronnie Heron, and as your host for the Astro Hour, I want to somehow get you into our weekly vlog, but doggone, it's the gentleman around me on the screen who will take over and carry the load of this incredible cutting-edge cosmology journey we do once a week from our very planet Earth out through the moon and the sun and the other planets to the incredible universe beyond. Our club meets inside on the first Fridays of the month and outside on the second Saturdays in the dark up at the Santa Barbara Museum of Natural History. And we are also out at colleges and
Hi, Tom.
Hi, Jerry.
and even, gentlemen, even shopping centers. How in the world do you set up telescopes at a shopping center? We do it. We'll find out here in a minute. We're also on YouTube, got our own channel. Outreach is SBAU.org, tells everything. Let's see what we're going to talk about real quick. Let me run down today's headlines. First an Earth-lit crescent moon, then distant planet Mercury, both rising early Thursday. How about the bright dog star Sirius and the winter constellation Ding going down? Gonna do an update on why stars twinkle this week. In Canis Venatici, the hunting dogs, it's a bright galaxy with a Messier number, 94. We'll tell you why you should zoom in on the moon's southwest quarter during Tuesday, tomorrow morning's early before dawn session outside. Somehow the Webb, get this, the Webb scope took a picture, took a look at an exoplanet's surface. Whoa, something we all, let's see, it's all round and it's way out there at the edge of the solar system. My God, and it's mysteriously growing its own atmosphere. And this interesting statement from President Jerry's weekly talking points: solar activity makes space junk crash to Earth faster. Yes, of course. How massive black holes grow. Maybe. Let's meet the gang, shall we, ladies and gentlemen? Once a week he becomes Professor Jerry. Otherwise, he's our Prez, Jerry Wilson. Hello, and thank you for keeping this.
Good morning. Good morning, Joyce. And good morning, Calvin. And good morning, Riley.
You notice he leaves his wife, Pat, out of that every week. Leaves it up to me. Our First Lady, Pat Forgy.
Good morning, Pat.
That's right. Well, he keeps us alive. She keeps them alive. Here's Captain Outreach, also married to a Pat, and his name is Chuck McPartland, who's been around forever and will never die. And he's part, I guess, a vampire because he lives outside at night. Here is, he's married to Pat McPartland, who is our treasurer and esteemed merchandise manager. On the screen, joining us early was Tim Crawford, who's married to Karen. Hi, Tim.
Howdy.
Working on a dynamite speech for the December in-house members-only party, which is 7 months away. How's Karen doing?
She's doing pretty good. That garden outside is getting big.
Okay. And I think this is also a cat lover. Maybe he owns one, Tom Whittemore. I know he likes birds, so I'm not sure. How you doing, Tom?
Fine. I like dogs.
Oh, you're a dog guy. All right. He's married to Maureen and has dreams of Westmont College and the old days running his own science lab.
And Wally
we
Dog.
do the silly cartoons every week on the Astro Hour to get us in a good mood, and we laugh our way through space afterwards. So we had 6 sent to us. These are President Jerry's forwarded silly science things. The Bizarro one, can you enlarge it a little bit? Is that possible? And I'll let you tell us what's going on there.
Well, there's this lady at the beach and she spots this parade coming up out of the sea.
And all right, everybody
she
back
says,
in the water.
All right, everyone back into the water. There's too many of us already.
Pretty good.
And there's a piece of pie up here.
Where?
Dynamite.
An eyeball there. And as Chuck points out, there's a dynamite here. These are all things that whoever does Bizarros.
Dan Ferraro.
Yeah. He puts those in most of his, if not all of his cartoons. Yeah, that is Dan Pizarro. Piraro.
There's
Okay.
usually a K2 somewhere also. I'm not seeing that.
Behind her on the sand is a slice of pie. I
Yeah.
don't,
Yeah,
why?
He just puts that in all. That's a signature of his cartoons.
yeah.
Oh, I see. But he doesn't do blocks, a series, 3 or 4 squares.
Sometimes.
Oh,
Yeah,
sometimes.
yeah, sometimes it's a panel.
Sometimes in your Apple Music library, you can ask me to play a radio station or ask for your music.
Go away.
It was,
Oh, my phone was listening in and somehow I must have said Siri.
Oh, yeah, okay.
Well, Chuck, since you're our meteor guy, why don't you guide us through this? What is going on? I see the word meteor there.
Okay, got a bunch of dinosaurs at a cookout with their George Before Man grill
Oh, I didn't see that.
and cooking whatever they cook for their burgers. And one of the little dinosaurs says, "Wow, these burgers are." And the other one looks up and sees an incoming bolide and says, "Meteor." And then the cook dinosaur says, "Actually, that's true. I used less filler this time."
I didn't see that George Before Man grill. That's good.
Okay, how about you, Tim, guiding the cartoon sun? Also was talking to our moon, apparently.
Yeah, I got the looking sweet moon. Where did you get your bling? This old stuff? Yeah, Earth gave this back to me a while.
That's right.
Or gave this to me back a while or a while
Yeah.
back.
He's
Yeah,
got a
anyway.
necklace here floating around,
Yeah.
various flags.
Yep, we're going to pollute the moon, our nearest body there.
There's one of these that are great.
How about very scientific Tom Whittemore guiding us through this, what, a space fair or a science fair?
Yeah,
Yeah, it
science
looks like a science fair. There's an exhibit on black holes.
Okay.
And it says, one person says, I had no interest in doing this project, but I got sucked into it. He apparently is in charge of the black hole project.
Yeah.
That's your kind of humor right there. Okay, Mr. Prez, that looks like a Mr. Coffee talking
Yeah.
run by AI.
Yeah, they're getting AI into everything. The coffee maker pops off and it says, "You look tired." Mind you, you look tired all the time. And that hair sure doesn't help. That can't be the look you're going for. And she says that coffee has no filter.
That's good.
Oh, I didn't
Good
get
one.
that at first. Now I do.
As opposed to telescope. Okay, I'm
Oh,
going to do this one. Calvin and Hobbes are meeting in a UFO that's just landed. And of course, the tiger is astounded. Oh, UFO! And here come the little creatures from space. Take us to the supreme earthling potentate. And it looks like Calvin's going to take credit. He says, "Oh, well, speaking." Apparently, he knows who our leader is, doesn't want them to meet him. And the two creatures say, "Ah, what luck. It was I who chose the landing site. Kudos for Navigator Nebular."
Yeah.
Okay.
There's a more recent take on that where the UFO lands and talks to whoever spots it, says, take us to your leader. And the person says, "Only if you promise to take him with you when you leave."
That's pretty good.
Uh,
That's a good one.
oh, there's another. Gonna have to enlarge it.
Oh,
Jerry?
oh, this is good.
Oh, why did the chicken cross the moonscape? Anybody want to do that? Whoever?
I'll do it.
All right, Tim.
This one is okay. Okay, he's thinking to himself now. Who says we weren't bred for flight? And the thing I like the most is down on the bottom. It says Pollo 11.
Yeah,
Yeah,
that's good.
Pollo. Look at his flag.
Yeah,
Yeah.
with an egg on the flag.
Lay
That's
an
kind
egg
of
up
good.
there.
So is this the same guy that you see a K2? I don't see the K2
Yeah,
anywhere.
well, there's O2 at least on the arm on the wing of the chicken. There's the eyeball down below.
Oh,
disguised
K2
as a rock.
on his backpack.
Packback has the K2. You're right.
Yeah.
Where is the pie?
Oh, is this the Bizarro guy?
Yeah,
Yeah, same guy.
yeah. I'm not seeing the pie anywhere.
But that's the NASA logo on his shoulder, isn't it?
Yeah.
Yes.
Wow.
Mhm.
But I really like that one. Pollo 11.
Yeah.
Well, it's close. All I need today. Tom Whittemore, what the heck's going on? Mouse maze? on an island?
Yeah, not sure. Well, there's a maze, right?
I
Yeah.
don't get this
Welcome
one.
to the island of mixed cartoon cliches. Uh, there's a piece of pie.
There's
Yeah,
the pie
there's the pie
That's the only thing I got from this one.
and a shoe.
and
Well,
an
a
eyeball.
common motif in cartoons is the two people stranded on a little island with only one tiny palm tree,
Yeah.
and then the rats in the maze. So that's the two cliches.
Hmm.
Oh, okay. I didn't get it, but now I
Yeah.
get it. I don't see
Okay.
I don't see I see the piece of pie, but I don't see a K2.
Yeah, I don't either.
There's a shoe.
There's a shoe.
Yeah,
There's the
shoe.
eyeball.
Yeah.
I'm sorry, what is a K2? What are you talking about?
The things that he always puts in his cartoons.
Is a K2?
One of them things, yes.
Okay. K doesn't stand for any word that we know.
Don't
Okay.
know. He's a weird dude, man. I've never seen these before. Jerry put these in, and they're all good.
Now
Yeah.
these when they when uh they were always interested in the this is an a sidebar based on K2. The people were interested, geographers were interested in what was the tallest mountain on the earth. And people could only survey them from other mountains. And so they surveyed whatever they could in
Himalayas,
the what?
the Himalayan mountains.
Yeah, the Himalayas, thank you.
Yeah, K2.
And they got and they had all these named peaks. And then when people developed airplanes, they didn't do surveys anymore. They went over the area and they took stereographic pictures, sets of pictures, and they measured the heights from there. And it turned out that as they expected, Everest was the tallest peak in the mountain change, but the second tallest peak had never received a name, so it always stuck with its map coordinates, K2.
Oh,
Well, you know, I heard from, I think Neil deGrasse Tyson says there's a mountain down in the Andes that's actually further from the center of the earth due to the bulge at the equator than Everest.
Yeah,
The
the
top
Earth
of
isn't
Everest.
exactly spherical.
And if you just take height above the local sort of lower level, probably Hawaii, the Hawaiian Islands are pretty tall too.
Yeah.
Yeah. They have a lot of buried mountains under the ocean.
you know, on that cartoon, maybe the K2 refers to when they were going to have all the computer problems in the year 2000.
No, that was Y2K.
Oh, well, maybe this is equal to pi is equal to K2.
Okay, moving right along.
There's the
This
moon.
is
Too much
the,
math.
This is Mercury and Earthshine on Thursday morning. The moon is, as you can see, is a crescent, a waning crescent. It's about halfway between last quarter and new. You can see the Earthshine on it, and this is what it's going to look like. It's not a picture from next Thursday. This was taken of the same situation several years ago, and this star out here is Mercury.
Hmm.
So there will be a similar thing in the morning sky on Thursday morning.
Yeah, look at the detail you can see on the moon, away from the shine. Look at Crisium on the top,
Yeah.
or as Chuck would say, the basketball, right?
Or the soccer ball, yeah.
You know, Tommy, it was a few Westmonts ago. I
Yeah.
opened the gate to the baseball stadium, and there was a real low, young crescent on the moon, and
Oh.
I got that one of my eyepieces just filled the eyepiece with that crescent, and the Earthshine was just as good as I've ever seen.
Yeah, that's neat.
It was really beautiful.
Yeah, a lot to be said for the moon, huh, Tim?
Yeah, yeah.
Now, if you look at this, you get a Earthshine type situation with a crescent moon also in the evening, not at this time of the lunar cycle, but in the evening about 2 weeks from now. No, about a week from now. About a week
Yeah,
from
and
Thursday.
and also coming up about a week from now is you're going to have that crescent moon very close to Venus.
Yeah,
Oh,
Yes, in the evening sky.
yeah.
And when it's in the evening sky, this is referred to by people that don't get up early
Yeah.
as the old moon in the new moon's arms.
Yes.
But
Yeah.
since this is a waning moon, it doesn't work for
I
this.
never heard that.
Yeah.
Well, can I add my stupid question of the week?
Go ahead.
The crescent I'm looking at is on the bottom. I normally see crescents either on the left side or a right side, or I'm not sure if there's ever one on the top side, but this indicates to me the moon's orbit is above the sun. Is that,
You
does
draw
that happen?
draw
Does
an
that,
arrow right through this, and the sun points to the sun.
yeah,
Mhm.
does it
Sun's
ever,
right down there.
does it ever, is it ever beneath the sun? So we get a crescent that's opposite
Not
this.
in the nighttime like this. You can see the crescent in the daytime if you can pick it out against a blue sky, and then it's tilted all sorts of different ways. But when you see in a movie, which I have seen, science fiction movies or other movies, you see the moon in the sky, but the crescent horns are pointed down, implies that the sun should be up in the sky, but it's night.
Yeah.
So they don't understand. And that's up there with the other common error is to see an apartment house with a Newtonian telescope in it that's pointed down at the floor because they
Yeah.
don't know which end of the looks at the sky.
And
And Ronnie, the way you perceive this as being on the left or the right or up or down depends on the angle the ecliptic is coming up and down from the horizon you're looking
Right.
at. So
But where does the moon's orbit, its plane, how does it meet the sun ecliptic? Are they about the same? Does
no,
it,
they're about 5 degrees off.
oh, it's a little off.
That's why we
otherwise you'd
don't.
get a total eclipse every month.
That's right.
Does it orbit above our equator? Pretty much.
Above
Why is
and
that a hard
below.
question? Why is that a hard question? Isn't certainly not over the moons or over the North and South Pole.
No,
Now
but
this-
it does go above and below the equator.
Oh, it does. Okay.
Now
Yeah.
this is a map of Mercury
Mhm.
as it currently would look like if you had a telescope big enough to see it. It's in this detail, these are composite pictures taken from spacecraft. You can see there are regions where it's highly detailed and then regions where it's not so much because they didn't, and here it's not well defined. It wasn't these are from drive-by photographs. They didn't spend a lot of time at it, looking at every part. This is what it would look like, basically a full Mercury, which indicates that it is relative to the sun.
On the other side.
Yeah.
Yeah.
When I go like this, that's for life. Okay.
You know, one of our members, Andy Allen, when he first joined, he was looking for a project to do,
Yeah.
and he decided he wanted to image surface detail on Mercury. And he went off and got his, I think it was a 10-inch Newtonian at that time, and a webcam. And he went down to Mount Laguna near San Diego and camped up there. And he pre-aligned his scope in the evening, and then during the day, he imaged Mercury while it was up in the sky with the sun. And he took thousands of images, and then did a composite of the best ones and image surface detail on Mercury.
Yeah. Very good.
Wow.
It's better to do that during the day because the contrast between the bright object like Mercury and the dark sky at night makes it very difficult to control flaring and stuff. It's hard to see with your eyes.
Oh, that's interesting.
Yeah. Now this one, it looks a little bit like the moon. That is, it's a grayish sphere and it's got impacts all over it. There's no seas on Mercury, but the composition is very different. It's obviously had a lot of impacts, but to oversimplify it a little bit, Mercury is more of a core of a planet once, and it's very iron rich and heavy. The moon is based out of the crust of a planet. It's made out of the crust and mantle of the Earth, which was thrown off when another planet, Theia, collided with us. So they look the same, but the moon is much more pockmarked, and the craters are different shapes because of the difference in strength of the surfaces.
It looks like they got names for everything, every bump and scratch on the surface.
Yeah.
Yeah.
Now, when I say things like that, what I'm doing is, and I got in trouble for this one time, but I treat teaching as a power series. The truth is a power series, and I give the zeroth order term, which is ultra simple, but it needs other terms in it, some of which are negative to and positive with different weaknesses to get at the whole truth. And I got in an argument once at the research labs with a guy. He said, "You told me something that's wrong." And I said, "Well, you figured out that I gave you the first term so fast I didn't get to the second term to modify the first term."
Mm.
So I explained to him the philosophy of teaching that I had been taught. So we ended as friends.
And these craters, it's not showing crater names here that much, but there are musicians and artists.
Mm-hmm. And also a section of Italy up there, Chuck, upper left, Liguria.
Uh-huh.
That's the home of focaccia. That's where they make the best focaccia in the world.
Yeah, this is looking at big plains and mountains.
Yeah.
Focaccia? That sounds dirty. Sorry.
Focaccia, you've had focaccia, yeah?
Well, I've had people yell that at me. Hey,
I learned how to bake that at What's the Matter You?
Yeah.
Okay, moving on again.
Thanks, Tim.
well, one last question about Mercury. Is it full of lava, or has it got a huge metal core and a giant lines of?
It's a small planet. It was once solid lava, but
Okay.
small things cool off faster than big things. Um, I think it's smaller than Mars, and Mars has lost its magnetic field because its internal dynamo has wound down and frozen out. So I would expect that Mercury is at least sluggish, if not frozen.
So magnetic fields on a planet pretty much depend on movement inside the planet,
Yes,
right?
it has to be some kind of dynamo somewhere. Now, our moon has little localized fields that were frozen in when the moon had a much stronger magnetic field. And some of the rocks can retain that magnetism. And so there are little magnetic field regions on the moon. We covered that once.
Yeah.
Yeah,
to me,
and on the Earth too, at the spreading zones in like the Atlantic, you can see stripes of magnetism going back and forth different directions as the Earth's magnetic field flipped every couple of 100 million years.
Yes.
As the lava came up from underneath, it got that frozen in. So
Yeah.
you can look at the history by looking at the different layers of the lava that had come out along the
Right.
spreading
Right.
zones.
Yeah,
Now,
right.
the
That's how
flip,
geologists basically come to terms of how old certain parts of the earth are. Yeah.
wow. But
Now, this one is called seeing. In astronomy, we have a measure of the quality of what we look at through telescopes, about how still and calm the air is, and then we get a steady image of a star or a planet. If the atmosphere is very turbulent, meaning there's winds, different layers of winds going different ways, and turbulent layers, then you can get a lot of wiggling of the stars and the blurring of details on planets, and that's called seeing.
Yeah.
For things directly overhead, the path through the atmosphere is shorter. So that's as good as it'll get. And then if you look at things that are on the horizon or near the horizon, they're significantly more jiggly and difficult to see detail on.
Yeah, Jerry, at this time of the year, that star could be our sun. And yesterday, Tim and I were at the Palmer, and it was spectacular seeing now and then. Really, really beautiful seeing. You know, the sun is higher now when we do the outreach, you
Yeah.
know.
I don't know if it was Saturday night or yesterday, but somebody was asking me about the twinkling, Jerry,
Yeah.
and followed by the question, how can I tell the difference between a planet and a star? And that's a little bit more difficult. I just said, well, they're usually a little bit bigger and maybe have a little bit of color, like a blue or greenish look. I don't know that it would.
Yeah, it's also
They
the
tend to
steadiness.
twinkle less.
Yes, yeah, the steadiness of the light, Tim, will push you more towards that thing as a planet, you know, like Venus.
So it won't twinkle as much as would be the answer, right?
Right, even the sun twinkles, right?
Yeah.
Well, that kind of what I told him. I said it has a tendency to be a little bit more steady
Yeah.
when the other stars are going to be twinkling a lot. The planets being a little closer will be a little bit more steady. But it's interesting that they brought this thing that Jerry's talking about right here. They brought it up the other night.
Well, especially now that Sirius is down low, it twinkles like crazy.
Yeah, yeah.
Yeah,
If-
and there's all
however-
kinds of colors too, huh?
if our atmosphere is totally transparent, how in the world does it affect light waves?
There are packets of air going by that are at slightly different temperatures, and that affects the refractive index of it. Like when you
Right.
stick a straw into a glass of water, the water's transparent, but you can see how the straw seems to shift direction.
Oh,
Yeah.
yeah, I've seen that.
So that same thing is happening as the starlight goes through a packet of air. But then if you've got turbulence or wind, the packets of air change. And so you get multiple different uh, twists in the light like that. And so you see the twinkling.
Right.
And
Huh.
the density of different things and its ability to affect light like that is measured by what's called the index of refraction.
Mhm.
The air has an index and a vacuum have an index refraction of 1. And the index of refraction is the speed of light in a vacuum divided by the speed of light in the medium.
Right.
So in a medium like the glass or water, the speed of light is slower than it is in a vacuum.
Right.
And a tricky little question in physics is, why is that? Since the speed of light is a constant.
Yeah, yeah,
So think about that.
Right.
yeah. Very timely, Jerry. Really good.
Well,
And also we have Jupiter in this position almost in our evenings right now. So
Yep.
it's a good time to look at Jupiter and the 4 Galilean moons.
well, they sure did Saturday night.
Before the fog.
Yeah.
Yeah, before the fogs, yeah.
But don't they have devices on the big time scopes that compensate for this?
Yes.
What are
Adaptive
they?
optics.
What's it called?
Adaptive optics.
Adaptive optics.
Yeah. This is also a beautiful time to look at Orion. I know Jerry's got it on the lower screen there.
Yeah.
And it looks like Orion is just leaning in. It's really neat when he settles, to the horizon.
Yeah, this is the western horizon. It's looking west at sunset.
Yeah.
This is the constellation top half of Orion with the belt here. And the winter has the brighter stars. And so we're saying goodbye to those stars till next November.
Yep.
Yeah.
So
Like we couldn't pick out Orion, I think, on Saturday. It was just too low.
yeah.
Yeah, and right now it's kind of neat. When we don't have fog, you can see that Venus is getting close to Auriga. It's really pretty.
Yeah.
You can see, Capella is a bright star, but considerably dimmer, than
Yeah.
Venus is.
I
Boy,
don't,
Venus was almost like a flashlight.
Yes.
Yeah, it's really pretty.
I
Really.
don't know how any of those telescopes on the star party see Venus. It's way over there behind the trees and the
Oh
buildings.
no, we could easily from where I'm at, easily.
Really,
Mhm.
I guess it's different up above.
And it's getting pretty high now.
Yes.
Was it?
Yeah.
It's heading up to meet with Jupiter.
Is it going to do that, Chuck? I was going to ask you that.
Yeah. I mean,
It-
it's going to take a couple of weeks, I think, but
But it'll be really close, huh?
yeah.
Oh, how
Oh
neat.
wow.
Two of the brightest planets right there.
Yeah, that'll be neat. That'll be neat.
So this down here, as the chatter indicates, is the brightest star in our sky. This is the second brightest. And then the famous Betelgeuse over here, which apparently is going to go supernova sometime after midnight.
Yeah, that's good.
Tonight?
That's a joke, folks.
Yeah, I know.
That's a Tom Totten joke.
Yeah.
Got your instruments out there every damn night.
Have you noticed Tom Totten's license plate on his truck?
No.
Nab Gib.
Yeah.
Yeah. Yeah.
That's the Big Bang backwards.
Yeah.
Oh, I'll be darned.
That's if we have an oscillating universe. So you get a Big
Yeah.
Bang and then a Gnab Gib.
And have gig.
Another little point for Ron is you see Procyon up there in Canis Minor.
Okay.
It means before the dog. In northern climates, it rises before Sirius does. And if you just track how it's going to set in the evening, it sets almost due west. So if Jerry's got it on Procyon, goes to the west, that's where it's going to set over there.
Huh.
As
I
well
didn't
as
know that that's what it meant before the dog.
before the dog, yeah. In northern areas, it rises before the dog star. Okay. You wouldn't imagine that right here.
No.
And, look over there at Canis Minor. It's a hot dog.
Yeah.
Oh, here?
No, Canis Minor.
Canis Minor, the little dog.
Where Procyon is.
Yeah, Procyon and Gomisa.
Oh, that's that.
Yeah.
Yes.
Yeah.
Yeah.
So it's a hot dog.
Yeah.
Okay.
Oh.
The other, Tim, the other collection of stars that rise and pretty much due east and set due west is the belt of Orion.
Mhm.
So you can always guess, or gauge where east and west are from the belt.
Oh,
And Regulus.
that's interesting.
Regulus is right on the equator.
Is it really?
Yeah.
Boy, I've always told people at star parties about how you can always find north, providing that there's no fog and you're in the northern hemisphere.
Yeah.
You'll never get lost.
Yeah.
But
Now,
I didn't
this chart-
know.
Go ahead.
I didn't know about the belt of Orion or Regulus or any of
Yeah, it's
those.
pretty close to rising in the due east and then setting due west. You
Interesting.
get that sense, Tim. So the belt is right now. It's down now in this picture.
Yeah.
Okay.
Yeah.
But that's a problem too for people taking pictures of like the Orion Nebula,
Mhm.
because the belt of geosynchronous satellites is out there along our equator.
Oh.
So you're sitting there taking a time exposure of things like the Orion Nebula, and you've got all these huge communication satellites
Yeah.
passing through because you're tracking the nebula.
Mhm.
I've got a great story, but I'll tell it another time. Jerry's got to get back
This
on
chart is
topic.
a little misleading in the sense that the brightest thing in this sky
Yeah.
is Venus over here, which does not look the brightest, but this is going to be like looking into a headlight.
Yeah.
Good
Yeah.
eye in the sky.
So you see Venus is setting north of west.
Okay.
It's over on the right side.
Yeah. Okay, now why have I got that up there? This is the Croc's Eye Galaxy. Astronomy magazine says this is a hot item. And it
As
is
in
also
crocodile?
What's that?
As in crocodile?
Yeah,
Yes.
it's in crocodile.
Oh,
But someone else had it as another one, cat's eye. But that's not the cat's eye.
Yeah, cat's eye is in
There are multiple cat's eyes.
Oh, are there?
Yeah.
See, these popular names like Croc Galaxy, Croc's Eye, those are not official names. And they go through fads where different astronomy groups use them and then don't use them and they disappear. But M94 is right there in Canis Venatici. There's a lot of good stuff in here. This is about 10 o'clock at night, so it's the solid evening. The other one before this was at 8:30, which is not completely dark by now, by that time, like this time of year. But this it will be completely dark.
Yeah. And this is prime galaxy time because our galaxy goes around the equator pretty much. And so you're looking up out of it. In fact, in Coma Berenices there in that previous star map, that's the North Galactic Pole is up in there. And so that's looking almost straight up out of the plane of our galaxy.
Yep.
Oh, really?
Yeah. And this is the Virgo cluster up here with all sorts of stuff in it.
Yeah.
And the M94, I didn't really realize it was so close to Corcoroli. I never did.
That's a star hop station on the way.
Yeah.
Okay. So this is a picture of that galaxy, M94.
The core is washed out.
Yeah. Boy, a lot of distant galaxies there too.
Yeah.
Oh, man.
Okay.
Look at that.
Just
two arms.
There we are. Stop share. Okay. Now, what am I looking at there? Open with.
What do the four spikes mean on those three stars? That it was taken by the Hubble?
Or a Newtonian. It's just telling you what the suspension of the secondary mirror is like.
Are you seeing this share?
No, we still got the original.
Oh, that's my machine is locked up.
Yeah, because you're frozen in my view.
Uh-oh.
It's starting to get cold here.
Yeah.
So, I don't know how to get out of this in a graceful way.
Jeez. Well, we've lost you before, but you can come back.
Yeah.
But we're just sort of like lost children stumbling around in an alley when you're gone.
Okay.
Well,
I'm going to shut off my machine and start all back up. It'll take about 3 minutes.
see you
Okay.
in a
All right,
while.
I'm gonna
Okay.
point Chuck. I'm gonna say, Chuck, you take over, and
Well, this Croc's Eye galaxy, when you see the non-blown out version of the core, you can really see why it's called the Croc's Eye galaxy.
Hmm.
but there's not a
Or
whole
cat's eye.
crocodile, or there's not a whole
Just the eye.
alligator around it,
It's just the eye.
just the eye.
Now, I think there is an aboriginal crocodile constellation, but their version is dark clouds. They do dark molecular cloud constellations.
Huh. Well, that makes me wonder what makes it a croc eye. What would be different between that and an owl's eye?
You'll see when we get a view that's not blown out like this. It's a very distinctive looking eye.
Hmm.
Crocs, do they have like cat eyes? The
Yes,
slit?
they have
Yeah, they
vertical
do have a
pupils.
slit. Yes. Mhm.
Ah, yeah, that I'll never understand. How do they see through a slit?
Well, you can see through a gap in a fence.
Okay, Chuck's the host now.
Yeah, uh-oh.
There's supposedly an owl up at Shoreline Park.
Yeah. Yeah.
It's over in a tree, and they got pictures of it online. And last night at midnight or so, when I finally hit the hay, I'm wondering if I heard an owl or one of the mourning doves. Which ones make the little whoo sounds?
Oh, that would be a great horned owl at night,
Yeah.
not a mourning dove.
No.
Okay, well, it
And
lasts.
actually, Greg Whitman, who was at the Star Party Saturday night, before he came to our Star Party, he had a telescope, a different telescope, a birding telescope
Mhm.
set up, and he was showing people that the fledgling owls. It's not
Oh.
just an owl; it's a couple of fledgling owls,
Yeah.
baby owlets, and he was
Yeah.
showing them to people.
Can respect owls.
Mhm.
Wonder where the wise part came from. Why are owls considered
Athena.
wise?
Yeah.
Tom, do you know that?
Athena,
Yeah.
the Greek goddess of wisdom, was associated with
With
owls
an owl.
Is that what it was? I'll be damned.
because they're always asking questions. Who?
Well, I just wonder why Mother Nature goes one way with birds and give them stereoscopical eyes like we have.
Well, that's whether you're a predator or prey.
Right.
Is that what it is?
Yeah.
But
Like
some
prey
of them-
animals like rabbits have their eyes on the side.
Yeah.
But eagles and
Yeah.
other birds of prey have them on the side of their head, don't they?
No, eagles, they're looking forward.
Yeah.
Are they really?
Hmm.
I guess they are. And those two eagles they've got in the nest with the camera on them, boy, an eagle always looks like it's very angry. Why is that? Simply because we're used to the way they
It's the eyebrow look. Yeah.
eyebrows form. Well, here we are, four lost children waiting for.
I was gonna tell you a story and I can't remember what it was now.
Well, save it for December, for crying out loud. You're going to open for our occulting
Yeah.
outreach guy. I got it covered now. I can't wait.
Yeah.
Well,
And Tim's actually changed his topic. It's all mathematics now.
Yeah.
Yeah. Yeah, did you see, Tom? I got one in a row.
Yeah,
Oh, did you?
Yeah.
Yeah.
you're gonna explain plasma too, right?
Uh-uh.
He
I
talked
have,
about it.
I have trouble with that one.
Tim talked
Plasma
about it
is like that
yesterday.
clear stuff that's in your blood.
Yeah. Yeah.
One of the many English words is have a dozen meanings. I understand plasma. It looks like most of the stuff in the universe is plasma because the
Kind of.
stars are far bigger than the planets, and the planets are the only things, planets and asteroids is the only solid we got. Everything else is,
Well, there's molecular clouds that are not necessarily plasma,
that's true, I guess.
and they're big.
I often wonder what it would be like to sail through them in a spaceship. Would
They're
you hit,
very tenuous.
Yeah.
you'd be able, it'll be like going through the asteroid belt, right? You'd never
Yeah.
see one or hit one, certainly.
There
He's
we go.
back.
Hey,
Welcome back.
Here's
Show us
Jerry.
your vacation pictures.
Let's
Now
see.
talk to us.
Okay, I'm just working on looking pretty here.
Well, none of us are that. We'll never be
there
that.
we go.
Okay.
Okay, so we were looking at the Croc's eye. And that is right. Just got things adjusted a little bit here.
Looks like there's an explosion out of the right side of your head on the left side of our screen.
That's
the
the
triangulum
M33.
Looks like 33.
Yeah.
Oh, you've got a headrest. That's what it is. A headrest on your chair.
In
Here
a
we
dark
go.
sky.
There we go.
Okay,
There.
this is
That is
this
beautiful.
is the Croc's Eye Nebula taken by or download. The data was downloaded from, I believe it was Hubble,
Yeah.
and it was processed by an amateur R.J. Gabaney. It's one of the principals of the organizers of the Astro Advanced Imaging Conferences. And this is a relatively wide field of it. Some really nice guide stars here. But you'll notice this band in here. This is a band of unusually high star formation.
Yeah.
This is a close-up that is
Pretty spooky.
yeah. So anyway, this highlights this star forming ring around it.
Yeah.
Now, if you look at different eyes of things, they have different iris patterns, and this is supposed to represent a crocodile's eye.
Yeah, that's really something. So,
Yeah.
Ron, what color would you say the center of the galaxy is?
In this picture,
No, I just is for Ron. I love to ask Ron
Oh.
questions.
The picture of Sag A is always orange.
Yeah, yellow. So those are older stars.
But when it's bright, that means it's a region of forming stars just because of the brightness.
Well, the blue.
yeah, these are blue, and
Yeah,
these are
those are
hot
new.
young stars.
Those are newbies.
Yeah,
Wow.
these are oldies. These are like us.
Oldies. Yeah.
So it's a one huge nebula orbits that center of that
Yeah,
galaxy.
this is dust that will become turbulent and form into other stars.
Mhm.
And this is the region where all the star formation is happening.
Wow.
Amazing.
That's an incredible image.
Now, moving back to the moon for an instant, this is the moon librates, which means that it rocks back and forth. So as it goes around its new moons, it goes like this. And so it shows we can see over 50% of the moon, because when it goes this way, we can see a little bit of the backside on that. And then when it's this way, we can see a little bit of the backside on the other side. It turns out that this region of the moon is now tilted toward us with this libration. And there's a crater down here called Shikard. And that is very visible right now, or rather this week, because this is the waning crescent, which happens on Thursday like this. So you should be able to see this. That's not a common thing. Usually it's much closer to the edge and foreshortened with no visibility of the floor. So if you're up in the morning you can have a chance to look at Shikard.
And this is saying it's Tuesday morning, so that's tonight, tomorrow morning.
Well, yeah, okay.
If you wait till Thursday, the Terminator might be pretty close to that.
That's right. You're getting that would be the Earthshine moon. Good catch.
God.
So that must be Crisium, huh, Chuck? Over there on the left? Would you say that's
No,
the other way?
Crisium would
the-
be off on the right.
It's
Yeah,
the other way.
yeah.
Okay.
Now this is, we changed topics here. This is a composite picture of Mercury, not a foreign exoplanet, but this is a topic about the exoplanet, is that the James Webb Telescope for the first time has gotten a look directly at the surface of an exoplanet, not to image it, but to do spectrographic measurements of it, to see what it's made out of. Whoops. And this particular place, I've got to go back, so we're risking, get rid of this. And we go to this.
They didn't send us any pictures then, right?
It what?
We didn't get any pictures of this exoplanet. We just get a readout of elements in
That's
its
correct.
atmosphere.
Yeah, this is a little too big.
Which star are we looking at here?
This is looking at infrared images from, not images, infrared data from an exoplanet. From, though the exoplanet notation is not on there, but it's in the talking points. It is LHS 3844b. It's a relatively young surface. It has no atmosphere. It eclipses its star, and as it goes by, the star chops it off, and they look at the change in light to see what the different regions of it is like. And two infrared telescopes, the Spitzer Space Telescope and the James Webb Space Telescope, have both taken these measurements. The red ones here are JWST, and the blue one here is Spitzer. Now this is wavelength in the infrared. So 1 micron is over here. So visible light is out here off the chart. So this goes through short wavelength IR and out to the 5 to 7, which is the mid wavelength. This would be the NIR camera. This would be the MIDI camera. And then long wavelength is out here at 11 or 12.
Yeah.
So
the data is less reliable out there, huh?
Yeah. If it gets much bigger than this, it enters the realm of swag, which stands for scientific wild ass guess.
Yeah.
So,
or flip a coin.
okay. So this is the orange thing is the spectrum of magnesium and iron-rich mantle rock.
Wow.
As on the moon, as on Mercury, because these are comparing the spectra to Mercury. The volcanic basalt lava rock is this line, which closely fits that. Silica-rich crystal rock, granite. This is this line, and it does not follow that line. So this is an evolved planet like the Earth that has plate tectonics, and it makes things like granite and silica and sand. The things like Mercury don't. They're all volcanic basalt and iron-rich mantle rock. And so the exoplanet has no atmosphere, and it's mostly like Mercury in our solar system.
Same size, you think? Small?
A what?
Same size, small, or is it a big? Can you be a big rocky planet?
Could be. They
Don't
seem to be rarer.
The size, did we put the size in there? It's about 30% larger than our planet. So it's a super Earth. It's about 50 light years away, dark, airless world that resembles Mercury in composition.
It's amazing you can suss out stuff like this, huh?
Yeah.
That's incredible. That's just unbelievable. We've finally got the telescope to do it.
Well, why does a planet like us keep our atmosphere and something even bigger doesn't? I don't understand that.
Good question.
Wait a minute.
This one's quite close to the star. It's a
Well,
cool, it orbits a cool red dwarf every 11 hours.
Whoa.
So it's very close, and that's where its atmosphere went. The surface of the planet is at 1,300 degrees Fahrenheit.
So we'd be about twice our age, huh?
We'd be a lot older than that. It's an 11-hour year.
Oh God.
But with the more gravity, we'd feel that way anyway.
Yeah.
Amazing. And that's the only one that can do it, or is it picking and choosing? And can it do all the exoplanets this way?
No.
No, when they can, they do. So this one is let's see, in the statement, let's see, this planet likely only contains very little water, if anything at all. One possible explanation is that this exoplanet is a relatively young surface shaped by recent volcanic activity, where fresh lava has been broken down by micrometeorite impacts.
Wow.
However, such activity is known to release gases such as carbon dioxide or sulfur dioxide, which we're not seeing. So alternatively, the planet may be covered with a thick layer of dark, fine-grained material formed over long periods of radiation and meteoric impact, similar to the moon or Mercury with dust on it. Without atmosphere, the surface would be especially vulnerable to this process known as space weathering, which gradually breaks down and darkens rock.
But we pretty much concluded there's no way life could be on this sucker, is there?
No, not unless it's wearing spacesuits.
Well, life that doesn't need an atmosphere, doesn't breathe. I don't know. You're sure there's some microbes that can live in muck and rock and no air around.
Okay, we have time for one more topic here. And
8 minutes.
that is a TNO, a trans-Neptunian object.
This is the one growing its own atmosphere.
Is Siri talking again?
No, that's coming from you. Or from Tom. There, he just
I think Whittemore's talking to somebody in the background.
This is a small body far from the sun in an icy outer realm of the solar system, and it has mysteriously grown an atmosphere, which it didn't previously have. Now, Pluto does that.
We don't know that, but we know it's short-lived.
What's short-lived?
Any atmosphere that it might have, unless it's replenishing it.
Now, the way they tell that is they watch this object. This is an artist's rendition. They watch an object that has an atmosphere as a star goes behind it. Out here, the star is shining unaffected, but the atmosphere goes out to here. And so the star, as it gets here, it starts to dim, then it dims, then it disappears, and then it reappears over there. And this is one frame from a movie that shows that. I guess that's Japanese.
Well, this isn't one frame. This is the whole occultation.
Well, no, this is part of a movie.
Yeah.
Is it moving?
So this is a video. The graph down below. Now that's totally artist's rendition up above.
Right.
And then these are the frames from a video with the photometry showing how it dimmed. It's not a very good example because it doesn't show a gradual dimming really, but
well, it does. This would be a vertical line.
Right.
So it's a sloped line, and
it's a thin atmosphere.
Yeah, that's the signature of a thin atmosphere, and that's what it sees with this TNO.
So this is a dwarf planet out in the Kuiper Belt, like Pluto?
Yes. And Pluto does this too. Pluto has an atmosphere at perihelion and none at aphelion.
Well, it still has some of that helium. That's one
Does
of the
it?
mysteries that New Horizons brought out of it.
Okay.
That it's lasting longer than they expected because they expected it to snow out.
Yeah.
And actually, at an occultation that I did at Bakara once, there was a Pluto occultation, and I saw a similar light curve to this. So I was detecting the atmosphere of Pluto,
Okay.
but it wasn't a central. This is sort of indicating a central occultation
Yeah.
because it's symmetric, but my curve was asymmetric because it was just cutting across, not through the center of Pluto.
Yeah. It was off center.
But
Yes.
the
Good
white dot,
catch to be able
the
to see
white
that.
dot to the right, is that a moon or a star?
That's the star that gets occulted by the bigger
Oh.
body with the
Oh,
atmosphere.
okay, I got you. So you've occulted Pluto?
I've seen a Pluto occultation, yes.
Wow. Did you tape it? Video?
Yes, that's how I got the light curve that showed the atmosphere.
Okay, fantastic.
Now this is a star occultation photometrically measured where there is no atmosphere and it's highly magnified. But you come up here and you're starting to see the occulting body represents a sharp knife edge. And so you see a diffraction pattern. And then the occultation takes it completely down. But this is taken of the moon. And this used to be a very popular thing to do when us amateurs first got a hold of 1P21 tubes back in the 60s. And they could measure this is a very quick thing. It's highly magnified. But you could catch this if you were good at it. And what Chuck was saying.
Can you put that back up again, Jerry? I'm not going to speak necessarily for Tim, but I don't understand what we saw there. I understood the dip, the pan that gave, the occultation moment ago. I know
So-
what that means, but I don't understand what that means.
So, Ron,
Okay.
have you seen the pictures of the perfect image of a star? It's not a dot. Okay, if you take a perfect image with like a refractor with no central obstruction, you get a little dot in the center, but you get rings around it because of this diffraction effect. Because the light waves are affected by the aperture of your telescope, okay? And they're also affected by the edge of the occulting body. And so you see these rings appearing. That's like the Mexican hat structure. And then boom, the thing gets dimmed out.
We're not talking about the twinkling effect. That was
No,
earlier.
no, that's different.
That's
Yeah,
different.
this is a sharp edge versus a diffuse edge that you see with an atmosphere. This is the signature of no atmosphere.
Oh.
So
And
that
actually, from the diffraction pattern, you can get an idea of whether the body's elongated or not. And there's even a paper that just came out showing that even if you have a near miss, where you don't get an occultation, you can see this diffraction effect, and you can sort of tell how close you came to the asteroid that would have occulted if you were right at the center line.
well, Crawford, do you understand this?
From when they were talking earlier, you notice how quiet I was. But as far as the diffraction pattern, it's closely related to a star test.
Yeah.
And a star test is when we take a star and you focus inside of focus and then back outside of focus, and you really get an expanded or magnified effect of that diffraction pattern, these rings around a star. So when he said that, yeah, but again, you notice how quiet I was.
But whatever this body is, it comes in on one level on the left side of the screen and ends up down below. Why doesn't it go back up to that normal level? What happened?
It will. It
It
will.
did. It did at the other
if you
end.
extended
But
this graph.
this is behind the moon, or excuse me, this is coming up to the moon, and then here it is going behind the moon.
Oh, is that so? That's what that represents?
Yeah,
That's the brightness of the star, and it goes away when it goes behind the moon.
yeah.
And how it relates to the atmosphere on a planet is that's where I get
Well,
confused.
this diffraction pattern would get kind of wiped out by the atmosphere.
Yes.
What is
I
the
see.
what is the straight line at the bottom of the picture with the number 5 next to it? What does that
That's your
mean?
axis of your
Axis.
graph.
Yeah.
Okay. So it'll go back to the normal high series of dots.
I
Yes.
off
should have
screen
just
to the
shown the
right.
upper part.
I
Okay.
think
You'll
this
see
is-
basically this thing reflected on the other side.
I
Yeah.
think this is kind of a graph of what Chuck does with his
Yeah,
asteroid
exactly.
occultation.
Yes.
Exactly, yeah.
Well,
Except
I'm
this is
looking-
the moon doing the occulting, and he does it with an asteroid.
Yeah.
And
So
there's
you go
there's a
up-
diffraction pattern like this that shows up in my moon discovery, which they use to help get some of the size of the moon and whether it was occulted along the edge or not, and the shape of the asteroid that went through. So in
Uh-oh.
December, I'll talk about that. But
Uh-oh, Ronnie, you're gonna need help with this.
Yeah, Whittemore, I hope you're coming with Maureen in December because Chuck's gonna do a whole half hour with a PowerPoint show and everything on discovery of a moon that you can't see, but you know it's there, right? Because it blips or something in your telescope.
right.
Right. Well, maybe they all have stars or moons of their own. Who knows?
Well, it
Okay,
seems to be pretty common because it's up to, I think, at least 400 now asteroids with moons.
Gonna be an interesting night. Gonna have to be really good to be as funny as the last December. You remember how crazy that got? On a vacation.
yeah,
Gents, that'll do it for program number 272. We'll do it again next week at 11 a.m. if you'll join us. And thank you very much. We have our own way of saying goodbye in the SBAU, and that would be
Asta Nebula.
got it.
goodbye.
Bye.
Thanks.
Thank you. Thank
Bye,
you.
everybody.